Uh, Hi. In today's class, we're just going to deal with just one problem. This problem is called the wine storage problem, and it's associated with the bigger subject called optimal timing. Optimal timing means we will be trying to find a moment at which it is optimal to take some action. And look, the problem we are going to do here is going to be very easy. But even though the problem is very easy, I believe that it conveys a very important message, and what the conclusions that we're going to get today can be generalized to every other problem in which you need to choose optimal moment at which you need to take some action. Okay, but let's get to the problem. This is called wine storage problem because, of course, we will be dealing with wine. Okay, imagine a case like that. You buy a case of wine for K dollars. So case is the price of wine in dollars. But look, you do not buy this wine to enjoy its taste. You purchase this case of wine as an investment because you know the value of this particular wine is going to be growing over time. So, now, because we know that this wine is going to be worth more in the future, because the value of wine generally grows with time, let's denote that V is the value of wine at time t. Well, of course, in normal circumstances, we cannot be 100% sure how much is our wine going to be worth 1 year from now, 2 years from now, 10 years from now. But let's just say that in this particular case, we've used an advice from some econometrician, and this econometrician calculated that the value of wine, of this type of wine, usually grows according to this function, where K is the initial price of wine, and then times E to the power square root of t. So look, here we have future value of wine. At time 0, right, this turns into 1, we just get K. So this is how much we paid it today. But in the future, this wine is going to be worth more, according to this function. Of course, maybe let's write it right away in this form, because we will be differentiating it, as you might expect. But let's just foresee how will this function look like. So here we have t. This is the value of wine over time. Here we've got some k. So this is our initial amount that we paid for wine. And this is what we would see, right? This is exponential growth. It's not the usual kind we are using because we have square root of t over here. So the effect of time is pressure down, but still we will get a shape like this. So we expect that the value of wine will be growing, the bigger, so with each year, it's going to be worth more and more and more. Okay, because in this problem, we're just dealing with one case of wine, you can just take this one case of wine and put it at home. So we can say that we are not paying for the wine, for storing the wine. Actually, we do not have the tools to analyze additional cost of storing the wine, but we will, and in probably less than a month, we will do this problem again, but a little bit more complicated version of this problem with cost of storage. But look, if we do not have the cost of storage, the question that we now have is, at which time should I sell the wine? Well, from the graph over here, we see that the value of this wine is growing with the time. So, generally we know that the value of this wine is not going to stop growing, right? Which means that if we look at it from the perspective of just counting, we have value of wine, we have a wine which value grows with time, we have no cost of storage. So maybe we should keep the wine indefinitely. Well, if this is our investment, probably not the best option. Because, well, if you're going to keep it indefinitely, probably you will die before you have a chance to sell it. Well, but we should remember that even though in this case we do not have any cost in accounting sense, we still have costs in economic sense. What do I mean by that? Well, we discussed this previously, that $1,000 today is worth more to us than $1,000 that we can receive 1 year from now. Why is that? Because we have opportunity cost. Opportunity cost, in this case, could be measured, for example, by interest rate. Because look, instead of keeping your money in form of the wine, you can always sell the wine for a current price and put the money into a bank. And then you will be getting interest from the bank. So, before we actually start tackling this problem, we should take into consideration this. So, we need to make sure that we are taking into consideration opportunity cost. The fact that the later we will get the money, the more interest we will have, the more interest will be lost. Because we could have sold the wine, put the money into a bank, and then receive interest on this amount of money. So, this brings us to another step in the analysis. Before we can proceed, we should focus our attention not only on the future value, but we should look, even though this is the future value of wine, we should make it into our present terms. How do we do it? Well, just as easy as before. So we will just take future value of wine and we will discount it with respect to interest rate. And we will discount it having interest rate be, let's just say, some very safe interest rate on deposit in a bank. So now we can a little bit, we will get that this is k to the power e t 1 over 2 times e to the power negative rt. Or after simplification, this is just k e to the power t to the power 1 over 2 minus rt. Okay, and look, now we've taken into consideration the opportunity cost. So now we can try to find optimal timing. Okay, how do we find usually optimal, maximum of something? Well, we use calculus, optimization techniques, so first and second order condition. Okay, so first thing we should do is to calculate derivative of this expression. But of course, we also learned that we can help ourselves quite a lot if we are using logarithms. So, look, the function that we want to maximize is a equals to k e to the power t 1 over 2 minus rt. Okay, so first thing we're going to do is to logarithmize both sides, right? We are getting ln a equals to ln k plus, okay, let's do it in many steps, ln e to the power t 1 over 2 minus rt. We remember that we can take this exponent and move it in front of the logarithm. And at this moment, I hope everyone remembers that ln e is simply 1. So, this is what we've got. Okay, now we can just calculate derivative of both sides. So here we have 1 over a dt, right? Derivative of the function, derivative of a on the top and a on the bottom. Now, here, this is 0. Out of this, we're going to get 1 over 2 t to the power negative 1 over 2 minus r. Okay, now, again, one more thing we can do is to multiply both sides of this equation by a, and we are obtaining the derivative that we wanted. Okay, and now we can use first order condition. First order condition always states that first derivative needs to be equal to 0, which means that 1 over 2 t to the power negative 1 over 2 minus r times a must be equal to 0. Now, let's look at a. Look, this is some amount of money, and we have two forces. One that makes it grow, one that makes it fall. But actually, it doesn't really matter which one wins. Not this one will win at some point, but this we're going to see on the graph a little bit later. But this expression can be equal to 0 only in limit with t approaching infinity. So, for our purposes, for any non-infinite amount of time, a must be different than 0. So look, all we get from this is a very simple condition that 1 over 2 t to the power negative 1 over 2 minus r equals to 0, or that r, or 1 over 2 t to the power negative 1 over 2 equals r. to know what we have there. Well, on the right-hand side of this equation, we've got interest rate. This is pretty easy, right? This is how much money are we losing by not keeping it in a bank. So this measures the percent of the amount we would have if we would, so basically, if at some time t we would sell the wine, keep the money in put the money in the bank, we would get R in interest, right? Well, we would get R percent of this money. But the more interesting question is, what is this? Well, this definitely looks weird, but let's go back a little bit to our function that was giving us the value of the wine. This function was k e to the power t 1 over 2. And now look, let's find growth rate of this function. There are two ways. Like, we can do it step by step. So I can simply calculate the derivative of v with respect to time. Simply I get a derivative of this expression up front. So I get 1 over 2t to the power negative 1 over 2. And I can write the rest. Now, growth rate of v, this is simply dv dt over v, which in our case is 1 over 2t negative 1 over 2 k e to the power t 1 over 2 over k e t to the power 1 over 2, which simplifies itself, and we get 1 over 2t to the power negative 1 over 2. But remember, there's an easier way to obtain this result. We could logarithmize this equation right? If we differentiate now both sides, we will have here 1 over v times dv dt. So here we would get the growth rate of v, and it would turn out again that this is 1 over 2t to the power negative 1 over 2. Okay, so now we have established what is this weird expression over there. This is growth rate of the value of y, of future value of y. So look, in this case, what does this condition mean? Basically, it means that we should sell the wine at the exact moment when growth rate of value of wine is equal to the interest rate. So, how can we look now at those two expressions maybe differently? Well, imagine for a second that we step from continuous time to discrete time. We do it only to make the interpretation of this expression a little bit clearer. Okay, so look, imagine that the discrete points in time are actually years. So what does this expression tell you? This expression tells you by how many percent does your value of the wine you have stored in your home has grown, is going to grow this year. And what is interest rate is telling you? This is how much money you would lose. This is how much money you would lose. Of course, expressed as a percentage of the sum that you have, that you would lose by not selling the wine and not putting the money into a bank. So now, let's consider a very simple example. Now look, if this year value of wine has grown 7%, while interest rate in a bank is 5. And let's just say the value of the wine is 1,000. Right? So this means that this year, if you're gonna keep the wine and wait until it appreciates in value, you're gonna receive additional $70. Right? But if you're gonna sell the wine today, then you're gonna get 5% from the bank, additional $50. So clearly, at this moment, it is a bad idea to sell the wine. It's better to keep the wine because the value of the wine is growing faster than what you would. It is growing by a bigger amount than what you would receive from a bank, right? So, but of course now, if this situation would be reversed. If interest rate in a bank is 7%, it means that if you sell the wine today, put the money into a bank, you will have $70 more. But if you're going to keep the wine, the value of the wine is going to go by 5%. It's going to be worth $1,050 next year. So, the value of your wine increased by 5%. So look, this time, it was a good decision to sell the wine and just put the money into a bank. Because with that, we see that actually you are making more money. So now, the question is, of course, why? What happens if those two values are equal? Well, this is the exact moment at which you should sell the wine. Why is that? Because as you will see, growth rate of the value of wine, and you can actually see it from the function, is the function that is decreasing, while interest rate is a constant function. Okay, but we can check it. Look, because what you see over here is a growth rate. This is a growth rate of the value of wine, right? So GV is equal to 1 over 2t to the power negative 1 over 2. Now, how does this function look like? We can check it quite easily using first and second derivative. So GV over dt. So we've got that this is negative 1 over 4t to the power negative 3 over 2. Clearly, first derivative is negative, which means that this function is declining. What does it mean? Look, we said that this function looks like this. Right? But, so it grows, right? But look, even though the value of wine is growing with every year, it grows with every year by a little bit less and less and less and less. Even, maybe I said it, like, remember, each time when value of wine grows, it creates a bigger base. So you can sell it by a bigger amount this year. So in order to keep constant growth rate, right, we would need to have a situation when wine grows by a bigger and bigger and bigger and bigger number each year. But this is not the case over here. So even though each year the value of your wine will be bigger and bigger, it's increasing in comparison to base by smaller and smaller amount. This is why we see that the growth rate of t is actually a declining function. Now, if I'm going to calculate the second derivative, I'm going to get that this is positive 3 over 8t to to the power negative 5 over 2, and this is positive. So look, we've got negatively sloped, convex function, right? So let's put this on the graph. Maybe then we will be better able to see what is happening. So if we have some rate, interest rate or growth rate over here, and here we have time. So this function has first derivative negative, second positive. It's declining, but it's declining slower and slower. So this is growth rate of v, which is equal to 1 over 2t to the power negative 1 over 2 t. Okay, now how do we put r? R is a given, we treat it as a parameter, we do not have any, of course, impact on it. It can change, but we need to take it as being constant. So r can be drawn as a horizontal line. Okay, let me just make it into a line. Okay. And now, what do we see from that? Look, if I'm going to sell the wine today, over here, somewhere over here, it means that I will lose. Why? Because look, if I'm going to sell the wine, get the money, put the money into a bank, I'm going to get interest rate, so my money will grow by this many %. But if I'm going to keep the value of the wine, the value of the wine will grow by this many %, and by this many %, and by this many %. Then over here we see that this, so here we should definitely hold the wine. But over here is the opposite. Look, if I'm going to sell the wine today, I'm going to receive amount of money that is less if I would sell it here and keep the money in the bank at a given interest rate. So here we see that this is the region of bad decisions. And you see now, this is why here we have equality. This is the perfect moment at which to sell the wine. Because after this moment, you will be taking losses. And before this moment, you would be losing the money by selling the wine too early because it still grows at a fast rate. Okay, so look, after all this, we can make a little bit more precise what those two things are. Look, this expression is definitely growth rate of wine. Growth rate of the value of wine. So it tells you how much value of the wine is going to grow each year. So it will tell you how much money, how much more percent you will receive if you're going to keep the money in form of the wine for one more year, one more month, one more day. Have we ever seen such a category in economics? Well, of course. This is marginal revenue. You can think about this as marginal revenue because it tells you how much more money you're going to get if you're going to keep the money in form of wine for one more day. Over here, on the other hand, we've got interest rate in the bank or on some asset. Now, this one is telling you what is opportunity cost. Of not selling the wine. So, what cost associated with not selling the wine for one additional year, month, day. So how could we call it? Marginal cost. Look, basically, what we get at the end over here is the simple condition that marginal revenue equals marginal cost. Okay, let's continue with this example because there's a little bit more we can get out of it. Okay, first, out of this condition, we can find optimal time. We just need to solve this equation. Look, out of this, I'm going to get that t to the power negative 1 over 2 is equal to r, or taking both sides to the power of negative 1, we will get that this is t to the power 1 over 2, here 1 over 2 r. Now, taking both sides to the power of 2, we get that optimal time to sell the wine is 1 over 4r squared. And this is what we can put here on the graph. This is optimal time to sell the wine. Now, let's make an example. What if interest rate is 10%? What is the optimal moment to sell the wine? Well, we see that then we've got 1 over 4, 0.1 to the power of 2 is times 0.01. So we've got 1 divided by 0.04. So this is 25 years. You see, in this scenario, assuming that this is yearly annual interest rate, we should sell the wine after 25 years. Okay, and we are almost done over here. But do we really know that we've obtained maximum? Maybe this is a minimum. Well, our, let's just say, economic interpretation does not allow us to say that this is going to be a minimum because we've got a clear reasoning showing us that this must be maximum. But how can we prove it? Well, we need to use second order condition. So in second order condition, we need to calculate second derivative of A. So in other words, we need to calculate the first derivative of the derivative that we calculated previously, which was 1 over 2 t to the power negative 1 over 2 minus r times A. But look, here is the tricky part. Remember that A is a function of t, of time. So, if I want to calculate this derivative, I need to use product rule. So, I need to calculate derivative of this times this plus this times derivative of this. Okay? So, we get the derivative of, of this expression would be negative 1 over 4 times t to the power negative 3 over 2. Right? Times A. Now, for the second part, we have 1 over 2 t to the power negative 1 over 2 minus r times at. But then, you should remember one thing. This was our first order condition. That goes to this is equal to 0. Right? We want to know what is the value of the second derivative at the point where first order conditions suggest the slope of the derivative is 0. So here we know that this is 0. This part is gone. And out of this, we can get that this is negative a over 4 square root of t to the power of 3. And positive, 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 it is clearly negative. We can be sure cover the entire problem in one video. The second thing is, as I told you at the beginning, this problem is very simple, but it shows you fundamental way of thinking about making optimal decision over time. And you can generalize this example and this reasoning, and you will always end up at the same conclusion. Marginal revenue equals marginal cost. It always leads to optimal solution. Okay, people, and or maybe now good news. So we should have midterms soon. You should be happy because this midterm is actually going to be only on the 3 classes we have. So there is not much, but please remember to study for it hard because final exam is going to be far more complicated than what you're going to have on the midterm. And on the midterm, not only please know how to do exercises, but also how to derive the formulas that I've showed you. Growth rates growth rate of a sum, growth rate of a product, growth rate of a quotient, expressing growth rate as a sum of product of growth rate and elasticities, everything that we covered in the last couple of videos. Okay, so this is it for this week. Thank you and see you in the next video.